Alright guys, welcome to video number 2, where this is going to be a quick start guide on feeds and speeds. So this will get you up and running. The next video we're going to do definitions, and then we're going to keep going beyond that. Now I make these videos the best I can. I'm trying to run a machine shop, so just bear with me. I'll keep releasing videos as I go. I'll try not to waste your time. We're going to jump in this, and at the end of the video we are going to go over just bonus advice that I've learned throughout my entire life. I'm just going to kind of throw random advice on the screen of what I've learned. So if you can just bear with me on this quick start guide, this will get you going. So number 1 is going to be material, knowing your material. All right, even if it's going on a forum, quickly researching the material, how tough is it? What's the rockwool? So how hard is it? And then, is it abrasive? Is it not abrasive? What kind of tooling are you going to need to cut that material? So kind of getting going to investigator mode on your material. So, you know, because plastic is going to require different angles on your tools than steel. So that's number 1, knowing your material. Very next thing is going to be to know your tools. So what tools are you going to need? Now you do need to kind of know how to process a part, but that's a whole nother video series. I'm just going to assume you got some advice from somebody else, or you know what you're doing. But if you knew what you were doing on how to process a part, more than likely you don't need the quick start guide to feeds and speeds. So you have to figure out what tools you're going to use, and we're going to make videos on how to pick those out. But for now, let's stick to the criteria. You need to know what kind of coatings you're going to need, how many flutes you're going to need. You're going to need to know the length of cut, because when it comes to tools, I'll always look at, for example, end mills with the hangout as your arm. So if you take your arm and stick it out and somebody pushes on the tip of your arm out here, it's very weak, right? But then the closer you get to the shoulder and you push on your arm, the stronger it is. So you don't want to grab a 1.5 inch flute length if you're only milling a 1/2 inch. So make sure that you understand what your stick out needs to be, how many flutes, the coating, and so knowing your material, and then knowing what kind of tools and the coatings, and just kind of doing a little bit of research. Part of being a machinist is being an investigator. Learning how to investigate these things to know you're choosing the right things. So we have number 1, which is know your material. Number 2, know your tool and process that you're going to be doing to choose that tool. Number 3 is going to be, to get you started really fast, is going to be an app on your phone. We do live in 2025, so there's an app for everything. And this is the app that I use. All you have to do is plug in your information on material, tooling, and what kind of operation you're doing, and it will give you a rough feed and speed. So if you know the coating on your tool and things like that, that helps a ton. If you don't, do your best guesswork, and then you'll be able to get a rough feed and speed. And I'm just going to kind of leave this up, and I'm just going to use it as I talk, just so you can get an idea of what it visually looks like. And I want to say it's like $15 to $30. I'm not sure. I'll have to get on the App Store and actually look, but it's worth it. You know, you're going to save a lot of time, a lot of money. And I do not run, which we're about to go over this, I don't run everything at 100%. And again, we're about to jump into why I do that. And you can do whatever you want, but over time you're going to learn yourself. But if you just throw a little trust in there, read through the comments on this video, but there are other apps beside this one. This is just the one I like. So after you end up picking an app, you know your tools, you know your materials, the next thing I would suggest is building your notes. So let's say you work for a company, and for example, we have Esprit that we use, and you build a knowledge base up. Well, let's say you quit, get fired, run out of business, things like that. You want a journal, and you want your own notes on the side that you can bring with you no matter where you go. I personally use Google Sheets. And this is roughly, I made a calculator for the Mazak, and this is what it looks like. And this is all the hard work that I've done into it. You can pick the material, you can pick the operation, it gives you a velocity, it gives you a feed rate, and it gives you roughing and finishing. I can bring this with me wherever I go, no matter what software is being used, because yeah, it's great to build the knowledge base, but if you end up not using it later, or if your company switches software from Esprit to Mastercam and so on and so forth, you want your own little knowledge base, your personal knowledge base. And With that being said, let's say you use a spade drill and you go with the feeds and speeds on the chart that, or the app that I suggested, and you have to tweak it to get it to sound perfect on a specific kind of material. I journal that. So I say, okay, I take a picture of the tool itself, I'll put it in Google Sheets, I'll put the feed and speed beside it, add any additional notes, like, hey, make sure you change out the set screws, I had an issue with that, and da-da-da-da-da. So, personal notes. So when it comes to plugging this information into, so this will be the next one, this will be number 5. When it comes to the app, it'll give you the feeds and speeds, and you plug it into your cam system. So you've got Fusion 360, Esprit, SurfCam, Mastercam, all these different cams. They all have the same information. You know, you pick your tool, and then you give it a surface feet per minute, or RPM, or, you know, feed rate off a chip load. And we're gonna go over all these in the definitions, but for now, it's just you read, you plug. You read it, you plug it. So this next one is important. You're gonna have people tell you, especially on comments and feeds and speeds, and you know, it's like other YouTubers that teach machining. They're like, here, use this brand new tool on this perfect condition of material, and you can just run it at 100%. And you're gonna have people on the comments like, that's all I do. I just use the app and I run it 100% and it works perfect every time. If you're an experienced machinist, you know that it's just a ballpark figure is what these apps are for. They are not actually 100% correct. So what I look at it as, pretend the best analogy I can currently come up with, your optimal feed and speed is Superman, right? He's 100% strong, optimal, he's gotten a bunch of sunlight, super strong. Well, there are variables, kryptonite, that affect Superman, that affect your feeds and speeds. So such as hangout. Let's say you're only milling a 1/2 inch deep, but your tool's hanging out 1.25 inches. Well, that's just a little bit of kryptonite thrown at that feed and speed, and it makes them that much weaker. All right, let's say that your tool is dull. That's a big chunk of kryptonite. Throw it at his feet, he gets a little weaker. All right, and then let's say that you don't have coolant properly, your coolant's not properly level, and you have just mainly water. Well, that's a big chunk of kryptonite, and your tool's probably gonna blow up. Yeah, you could have the 100% feed and speed, but that's, again, you would have to slow it down, and your tool will last a little bit longer, but in general, you're gonna need the proper lubrication. And so there are all these things. I mean, it could be how rigid your machine is. Somebody could have crashed it a few times, and your spindle isn't at 100%, and you know, your app says, okay, run it at 2200 feet and 15. Well, let's say your machine isn't that strong anymore, or you grab a holder that's hanging out this long versus this long. There are a ton of variables from the head of the machine to the bottom of the machine that is going to affect your feed and speed. So what I suggest on this app is that you put everything at 70%. That'll give you a little bit closer. I've ran stuff at 100%, but it almost burns it up really fast. There's no reason to be a hero when you first start. You know, just get the job done. You know, you're gonna spend more time blowing crap up and burning up tools trying to run the feed and speed the best it possibly can, as opposed to just creeping it up. So starting a little slower and bumping it up is way better than just starting at 100% thinking that you're in an optimal condition. So slow down, put the feed and speed at 70% on this particular app. I'm not sure about other apps, but I put it about 70%, and it does generally it does a really good job. Okay, let's talk about a checklist. Check your coolant level. Make sure that your tool isn't hanging out too far, and that you've done your research on your material and tooling. Make sure that you use your app. If you're using the one I'm suggesting, lower it to 70%. All right, you're gonna want to slow your feed rate down whenever you're profiling a part or end milling it. That might not always apply to like drilling, but particularly end mills and pocketing and things like that, slow your feed rate down. If you hear chatter, slow the spindle down and then start bumping up the feed rate. Going to be hogging something on a mill, make sure you're clamping on a flat. So grind a flat on your end mill and clamp on the flat, because your tool can pull out. If you're using drills, make sure that if you're using a carbide drill or a spade drill that you're using coolant through. You can, like if you're doing, I want to say, I've been told by multiple tool salesmen that if you're using a carbide drill, you can do 3 times the diameter on depth without using coolant through. But if you're going any deeper than that, and I would stick to maybe 2 times the depth, that'd be a little safer. But I would say make sure you're using coolant through if you can. It's so much better on the tools. All right, and then other than that, I mean, you just got to do it. You know, you can talk about feeds and speeds all day long, and you can be scared about it, blowing it up. But dude, you guys got to break tools in order to know how to do feeds and speeds and how to push it. And then you're going to learn the sounds, you're going to learn the vibrations, you're going to learn to read the load meter, you're going to learn all these things to adjust it. But to get a good basic ground, you're going to need to use the app and then journal it. All this advice kind of compiles together. All right, let's talk about lubrication. Again, this is research, knowing your material and what it likes, what it doesn't like. All right, just let's say you're using that Synergy 735. Do your research on Inconel, aluminum, steel. If you're doing production, especially, you know, if you're doing 1 or 2 parts, just make sure you're in the ballpark and you're good to run. But if you're doing production, make sure you know what level it needs to be at. And also, whenever you're doing coolant, try to use an osmosis machine. If you're using tap water, there's mineral in the tap water, and whenever you see bacteria building up in your coolant tank, it's because you're using tap water, and the minerals and stuff creates bacteria, which creates that mold and so on and so forth. If you use a clean water, you'll have less minerals, less bacteria. It won't smell as bad. It will not build up, and you'll have to clean your coolant tanks as often. But anyway, sometimes, especially if you're on a manual machine, you're going to want to study, go to the machinist handbook, get on a forum, and figure out what oils, what Tap Magic and Molly D for tapping and things like that. You know, we've also, like, you'll use Synergy 735 on tapping aluminum or Molly D. You know, it might be better for your tap if you're using a cutting tap to use Molly D versus just blasting coolant on it. So doing a little bit of research, it goes a long way. It'll save you hours just getting on a forum, seeing the mistakes that people have made. Just type in, I mean, it's just Google. I mean, you just type in what you're doing, tapping, 6061, lubrication, and then just read what people are having to say, and then learning from other people's mistakes before you make your own. I'm just going to briefly shout out things that I've learned over the years about feeds and speeds that have tremendously helped me. Apply them to your life as you see fit. When I'm on a manual machine, I go a lot slower for the most part than I will on a CNC machine because of how rigid a CNC is versus a manual. A manual is a lot of feeling, you know, so make sure you stub up as much as you can. I see people hanging tools out like this and they're only cutting this, so stub up as much as you can. Use carbide loves to cut hot, so on a manual machine, I typically cut dry. And just remember that if you're doing close tolerances, that if there's a lot of heat in your part, to let it cool down and then measure. Let's see. And I bring this story up a lot about the shortening of the tools. One time I had a part, it was chattering like crazy, and for the most part, but I didn't want to slow it down because I'm doing production. So what I ended up doing, and I didn't have time to order different tools and things like that, I just shoved it up in the holder 100 more thou. It shut the chatter up, and it was able to feed right, and it was amazing. So just 100 thou, that's all it takes. Now the other thing is a frequency. So whenever you hear something like a high-pitched chatter and stuff like that, and you're doing like thin walls, you have to remember that it's a rhythm. You know, it's creating a frequency of some sort, and you have to interrupt that frequency by pushing the tool harder sometimes. So let's say you're profiling something and it's, you know, fairly thin, and you hear a high-pitched chatter. Sometimes you got to bump up the feed rate a lot in order to get past creating that vibration in your part. So, or if you're on a manual, sometimes you got to feed a little faster. So a lot of people baby their tools, including me. I baby a lot of my tools, and I shouldn't. Sometimes this stuff is designed to push. And you have to do your research. If you dig an end mill out of a box and it has no information on it, apply these methods to kind of get you in the ballpark. But if you buy a brand new tool from Ingersoll, Kennametal, Walter Tools, all these different places with brands and things like that, do your research, because these companies have, designed them, they have tested them, they have researched them, and they have organized all this information on the website. And a lot of people just forget to go on the website and they just do what they know to do, as opposed to doing the research and then pushing the tool. Because again, sometimes it's better for the tool to be pushed as opposed to, like, for example, on an insert, you have this radius. A lot of people, let's say it's a 30 thou radius. Well, a lot of people end up roughing 25 thou. And this tool is really meant to rough beyond that radius and do like 25% of this length, or, there's different rules and things like that. But if you get on their website and research it, they might want you to cut halfway up the insert, a certain percentage on a certain type of material, and you're over here cutting just on the tips, burning up the tips, as opposed to cutting on this entire length right here. And yeah, you might have to slow the feed rate down if you're cutting, that far into the insert, but it's better for the insert in the long term, and you're able to rough a lot more material out. So you have to develop a relationship with the material, develop a relationship with the tools, develop a relationship with research. And if you can do all those things, then you'll be able to, be in the ballpark and get the job done. So all this information is great. The only way to really do this stuff is to get out there, put your hands on it and do it. And the reason we love teaching manuals first is because you develop that relationship with the tool. If you're drilling, you feel it in your hand. You'll feel the vibration. You can kind of tell when you're burning the tool up too. Like if your spindle speed is too fast and you can feel it. So that's why we love manual machines. You develop that relationship. And then the other thing I would suggest is, like when it comes to drilling too, sometimes you don't feed hard enough and you're sitting there letting the tool rub. And while it's rubbing, it's heating this area up and it's burning up the tips of your tools. So again, you want to push it. So you gotta get that feeling and that relationship. And that's why I highly recommend doing manual machining first to get a feeling. I'll see people running manual machines roughing faster than people on CNC machines. And yeah, light and fast is good, but sometimes these tools, they want that material coming off. Sit down, get on a computer, research your material, research your tooling, research how you're going to process the part to make sure you're choosing the right tooling, look at the coatings, use the app to get the feed and speed, slow it down to 70%, go through your checklist and make sure that you're checking the coolant, slow your feed rate down, bump it back up, and then you're going to get used to that rhythm. And then once you get used to the rhythm, you'll be able to do any tool, anytime, any place, anywhere. But again, try to get on a manual. There are times where I've been at a customer's place and I've had to get on a manual machine and I've never used the tool that they had in the tool post. I never had used their chuck. I never used their machine. But I was able to make bushings and things like that because I've done all this in my shop. If all I've done is CNC machines and a customer was like, here, can you get me this bushing real quick? And I run a machine shop and I'm like, well, man, I've never ran a manual machine. I don't know. It's just embarrassing. So you got to learn these things in order to be a full, well-rounded machinist. And you're developing, if I can give you the best advice, you're developing a relationship with the tools and the machines. Get on different machines, use different tools, and then the universal connection of all these things slowly comes together, and then you'll be able to grab a random tool, a random machine, and you'll be able to make something happen. So but the only way to learn this stuff is to get out there, do it, and you'll be able to, over time, after breaking a bunch of tools, a bunch of tabs, a bunch of inserts, a bunch of drills, a bunch of end mills, you'll develop this relationship to where you can walk by a machine, hear a pitch or a noise, and it's running too fast, or it's hogging too much, or it's not hogging enough. And I've had, my dad many a times has walked by the machine. He doesn't even look at what I'm doing. He'll just listen and he'll bump up the feed and bump up the spindle speed and then just walk away, and then it sounds a lot better. So you develop a relationship with the sound. And if you can't hear anything, then vibration, maybe. Thank you guys for watching. The next video will be definitions. So we're gonna go over RPM, surface feet per minute, chip load, things that you really need to know. And then there's a giant category of things you'll probably never use, but I'll just briefly explain. That way you can just kind of lock it in your memory bank. But again, everything that we went over is mainly about developing relationships with tools, material, and your machines. So I hope this got some people off the ground. There's going to be a lot of opinions from a lot of machinists when it comes to this kind of stuff. In the end, you can ignore everybody and just do this stuff yourself, develop that relationship yourself, and ignore everybody else. Because in the end, they're not going to come and run your machines. It's going to be you. You're going to be alone on this because you're going to be on a machine. Now, you might have some help of, management or other people that are in your department. But in the end, everybody is winging it. They're doing their best guesswork, because there's a ton of variables that apply to feeds and speeds. So you can get in the ballpark, then you have all the variables happen, but you adjust as those variables come into play. And how you adjust is developing relationships with the tools and your machine and your checklist, making sure the coolant's right. So again, make sure that you get out there and you do it. Watching this is great. Downloading the app, that's great. But until you do some test cuts, you're not going to know. And also, last piece of advice, make sure that you understand the anatomy of a tool and how to tell if the tool is sharp. All these feeds and speeds, tips and tricks do not matter if you can't tell if the tool is sharp or not. All right, guys, thank you for watching. I will see you guys on the next video when it comes to definitions.